Okay, so today too, I'm looking at when you've been asked to find the variance of ax plus by. So anytime that you are given this, then they are saying that anytime you have something like this, then finding the variance is the same as what a squared multiplied by the variance of x plus b squared multiplied by the variance of y plus or minus 2ab covariance of x y. So what the plus or minus at the third expression means that, let's say if you have ax plus by, then it means that the third expression before the covariance is going to be plus. However, if you are asked to find variance of ax minus by, then the third expression there before the covariance is going to be what? Minus. Is okay. So I'm going to prove for the case of as plus by alone, then you can do for the minus. So let's say you have variance of, so proof variance of ax plus by. Is okay. Yeah, so we know that from our expression, we always know that variance of x is equals to what? Expectation of s squared minus expectation of x all squared. Great, so that's the expression. But in this case, you have, instead of x, you are going to write as plus by. You're going to write as plus by. So I'm going to have it as equals to expectation of ax plus by all squared minus expectation of ax plus by all squared. Is okay, great. So once I have this, when I expand this first expression here, I'm going to have it as equals to expectation of a squared s squared plus 2ab xy plus b squared y squared, b squared y squared. Yeah. And the second component of it is going to be the same as minus a expectation of x plus b expectation of y all squared. Great. So when I expand this expression, I'm going to have it as is equals to a squared expectation of s squared plus 2ab expectation of xy plus b squared expectation of y squared. Now, when I look at the second component too, that is also going to give me minus a squared expectation of x all squared minus b squared expectation of y all squared minus 2ab expectation of x expectation of y, yeah, expectation of s, and then expectation of y. So let's look at something. So I'm just going to look at the similar terms and then group like terms. So look at this expression, a squared, and then there's another a squared here, right? So I can group that and say that it's equals to a squared. So I'll factor out the a squared because that's common thing. Then I'll bring in expectation of s squared minus expectation of x all squared, right? So let's look at the next term is a b squared, right? B squared here. So I can see that the same as plus, I factor out b squared, then I'll have expectation of y squared minus expectation of y all squared. Is okay. So this is plus. Now the third term that we are going to look at is AB. So you have 2AB expectation of SY. So I'm going to have it as that part also is going to give you plus 2AB expectation of XY minus 2AB sorry, grouping item, that means yeah, the B should be out, the 2AB should be out. So the 2AB minus expectation of X and expectation of Y, right? So when you look at the first expression, which is this one, look at this. When you look at the first expression, which is this one, this expression is the same as what? The variance of X, right? This is also the same as what? The variance of Y. So that means I have A squared variance of X and then B squared variance of Y. So when I come again, I'm going to have it as A squared is equals to A squared variance of X plus B squared variance of Y. And this expression here is the same as what? Covariance of X and Y. So plus 2AB covariance of X and Y. So that means you have proved, because we said the variance of A, we said variance of AX plus BY is equals to what? A squared plus A squared, sorry, is equals to A squared variance of X plus B squared variance of Y plus 2AB covariance of X and then Y, right? So that we have proved here. Thank you.